Hello, today we are doing chemistry. There are some really good questions in here. And even if the questions look a little bit scary at the beginning, I'm going to show you how you can tackle the questions so that you can still get some marks, even if you don't get all the marks. This is a really good attitude to go into the exams with. Just trying to get as many marks as possible, picking up things all over the place. So I've got a question paper like I did yesterday. Let me just share my screen with you. So hopefully you can see my question paper now. I'm going to go through it. I'm going to write on here so that you can see anything that might pop up, anything that would be important. I'm going to read out the questions. I'm going to give you a little bit of time to go through the questions yourself, writing on either the paper that you've got in front of you or on any bit of paper that you have. And then we'll go over the answers and I'll show you a few hints and tricks where you can use in the exam to pick up some more marks. So a nice short 2-mark question to start us off with. The method used to extract a metal from its ore depends on the position of metal in the reactivity series. Aluminium is extracted from its ore by electrolysis. Explain why this method is used to extract aluminium from its ore. So you've got 2 minutes now. I'm going to mute myself, give yourself 2 minutes to answer this question, and then we'll all come back together and we can go through the answers. 2 minutes. Thirty seconds left. Okay, so the key thing with this question is actually understanding what it wants you to write down, because there are lots of things we could write down for this relating to the reactivity of aluminium, but it is key in the question why it is asking you why we're using electrolysis to extract aluminium from its ore, not just using carbon reduction. So we need to clearly show the examiner that we know that aluminium is very reactive and that it is more reactive than carbon. And because it is more reactive than carbon, we can't use carbon to extract it from its ore. So it can't be reduced by carbon. We also need to say why we need to use the electrolysis. And what is particular about electrolysis is that it requires a lot of energy to separate aluminium from the oxide. So separating aluminium from the oxygen that is in the aluminium oxide ore. So you can see I've clearly linked the reactivity of aluminium back to the question why we specifically needed to use electrolysis for this question. Okay, 2 marks there. Give yourself a couple of ticks, see how you've got on, and then we can move on to the next question. So question 2 for 4 marks, and this is a maths question. The formula of aluminium sulfate is Al2, open brackets, SO4, close brackets, 3. Calculate the total number of atoms that combine to form 5.13 grams of aluminium sulfate. The relative atomic masses: oxygen 16, aluminium 27, sulfur 32, and Avogadro's number is 6.02 times 10 to the 23. 4 marks. I'm going to give you 4 minutes to calculate the number of atoms. Halfway through, you've got 2 minutes left. 30 seconds left now. Okay, this is a tricky question. The really good thing about tricky questions like this, and yes, I promise you, these are a good thing when they come up in the exam, is that there are so many ways you can get marks. Even if you look at it, maybe feel a little bit intimidated by it, you can still just jump in, do some things and get marks out of those. So there are loads of clues here as to things we can do to get marks, even if we're not 100% sure how to get all the way through to the end to get the number of atoms. So some of the clues that they've given us the relative atomic masses of oxygen, aluminium and sulfur, and they've given us the formula of aluminium sulfate. So what I want you to be thinking whenever you see this sort of thing written down in exam, first thing I want you to do is to work out the formula mass. Even if you're not sure where we're going to go after that, let's just work out the formula mass, because chances are that's going to be a mark in the exam. And I will tell you for this question, working out the formula mass of aluminium sulfate is going to give us our first mark. So there are lots of tricky things in here. This is a particularly tricky question. So I'll move that down, give myself a bit more space. Now, because we have brackets in there, what we actually have is 3 sulfurs, and then we actually have 12 oxygens. That is a lot in there. So I'm going to break this down into a couple of different parts when I work this out. First thing I'm going to do is work out the mass of the sulfate. So we have sulfur, which is 32. Oxygen, which is 16. And there are 4 of those. So I put the brackets in there. So if you want to put this into your calculator along with me, you can. So 16 times 4 is 64, plus 32 gives us 96. And then we have aluminium over here, that is 27. That is going to give us 54. Now, we actually have 3 lots of the sulfate, remember? So it's 54 plus 3 lots of sulfate, 3 times 96. So 96 times 3 gives us 288, plus 54 gives us 342. So that's our first mark there, working out that the mass of this is 342. Now, in chemistry, the way you get from one place to another place is by working out the moles. So if you're really not sure what to do in any equation, just try and work out the moles, and then chances are there's going to be a mark for working out the moles in there somewhere, because everything is to do with moles in chemistry. So if you ever see a maths calculation, you're not very sure how to approach it, just aim to get to the moles, and if that's as far as you can get, that's as far as you can get. Remember, to get these top grades, to get those 7s, 8s, 9s, we do not have to be getting 100% in our exams. Like, we can still lose 1 mark on this question, we can lose 2 marks on this question, and still come out with a really fantastic grade at the end. So don't just look at this and feel kind of like slightly paralyzed, intimidated. Always just try and get to the moles. So for us to work out our moles, we're going to pop back to the question, because what we need to find in the question is the mass. So there is our mass. So we have 5.13 divided by our MR, which we've just worked out, which is 342, which is going to give us 0.015. Oh, messy 5 there. My messy 5 there brings me to a really important side note. When you are writing your numbers in an exam, let me do this in a nice colour. When you're writing your numbers in the exam, please make sure it's very, very clear which numbers you're writing. I know some people like to write their ones like that, but then is that a 1 or is that a 7? And you can see if it's not very clear to you, if it's not very clear to me, then it's not going to be very clear to the examiner, which makes it really hard for them to give you marks. So please write your numbers nice and neatly. For example, what number's that? Is that a 6 or is that a 0? So please, nice clear numbers in the exam. So we've got our first 2 marks. We've worked out the MR and then we've worked out the number of moles. And what I'm going to do is I'm just going to put a little note next to this number so I'm very, very clear what this number is. Because when you're doing a calculation like this, and you'll see as I'm doing this, there's a limited amount of space here. And well, my handwriting is quite large. And I'm trying to show this out as clearly as I can. It can get a little bit jumbled, it can get a little bit confusing, it can get a little bit all over the place. And then when we get to the final step and you're going back and you're looking for a number that we calculated previously, you need to make sure you're pulling the right number out of all the calculations we've done previously. We don't want to accidentally use 342 when we should have used 0.015. It also helps signpost to the examiner that you know exactly which bits you're talking about. I know it may seem like an unnecessary waste of time, but clearly signposting to the examiner what numbers are what is really going to help them give you more marks if you've made any mistakes, if they can clearly follow through all of your working. So this number here is the moles. That is the moles of aluminium sulfate there. So I've just made myself that tiny little note. Now, this is kind of like, this is where the tricky leap that we need to make here, because it says the number of atoms and it's given us Avogadro's number. So we know now that we need to do something with that. So I always like to start with kind of like looking at the number of moles, the number of atoms in 1 mole. So if we had 1 mole of something, if we had 1 mole of sulfur, we would have 6.02 times 10 to the 23 atoms. But in aluminium sulfate, well, we've actually got quite a lot of atoms in there. So we've got 2 aluminiums, we've got 3 sulfurs, and we've got 12 oxygens. So 12, 3, and 12, 3, and 2. That gives us a total of 17 atoms. And again, I'm just going to make myself a little note. So I know exactly what that number is referring to in the future. So 17 atoms in aluminium sulfate. So this is where we can bring in Avogadro's number. Just going to draw a box here, and then I'm going to label these step 1, step 2, step 3. So it's a little bit clearer for you to follow through the paths if you're ever so slightly behind. So now we're going to work out the number of atoms in 1 mole. So 17, the number of atoms in aluminium sulfate. Times 6.02 times 10 to the 23, which is Avogadro's number. And that will give us 1.0234 times 10 to the 25. But that is the number of atoms in 1 mole. And we don't have 1 mole, we've got 0.015 moles of aluminium sulfate. So step 4 is now I'm going to work out the number of moles. Well, I'm going to work out the actual answer. I'm going to work out the number of moles, the number of atoms in 0.015 moles. And that will give us our final answer. And I'm going to write that in the answer space down here. So that is going to give us 1.5351 times 10 to the 23 atoms in 5.31 grams of aluminium sulfate. That was a mammoth question for 4 marks. And even if you didn't manage to get that fourth mark there that I've written in point 4 in black, I really hope that everyone would have been able to attempt point 1. Everyone would have made the leap. I need to go to moles to point 2. A fair few of you would have been able to recognize we need to use Avogadro's number and then actually calculate the number of atoms in 1 mole. And then even if you couldn't do that last part, 3 out of 4 marks on a tricky question like this is still very, very respectable, even for a grade 9 student, for a grade 8 student. So even if you didn't get all the way there on this question, because it is really nasty, then please just be really happy with 3 out of 4, be really happy with 2 out of 4. We do not need to be getting 100%, 100 marks out, all of the marks in your exam paper. So always jump into these questions, try, look for the clues as to what the examiners are going to give you marks for. So here are the clues with the relative atomic mass. Always go for moles whenever you see a maths question. Like, you may get marks for it, you may not get marks for it, but it's at least doing that calculation, worth doing that calculation, writing it down, and then look for any other hints that the examiner's giving you. Really big question there, guys. So write down how many marks you get, and then we can move on to the next one. Question 3. The word equation for the reaction between copper carbonate and dilute sulfuric acid is copper carbonate plus sulfuric acid gives to copper sulfate plus carbon dioxide plus water. Complete the balanced equation for this reaction. So they've started you off. They've got copper CuCO3 plus, and then a blank space with an arrow, and then another blank space, plus CO2 plus H2O. Now the first part after that, the second part is to calculate the relative formula mass of copper carbonate, CuCO3. And then we need to, what is the chemical test to show that the gas is carbon dioxide? So that is 5 marks there. I'm just going to leave that there like that. Even if you don't see all the multiple choice options there, you should hopefully know what the answer to that one is at the bottom there. I'm going to give you 5 marks to have a go at those 3 questions yourself. You've got 2 minutes left. Okay, let's have a go at this question. So we need to start off by completing the balanced equation. So the word equation for this reaction between copper carbonate and dilute sulfuric acid is copper carbonate plus sulfuric acid goes to copper sulfate, carbon dioxide plus water. So they've already filled in copper carbonate for us, carbon dioxide and water. So we need to fill in sulfuric acid and copper sulfate. So the first part is just a recall. The first part, we are going to write down the formula of sulfuric acid, is just a recall question. And this is one where lots of students fell down because they couldn't remember or couldn't even fully remember the formula for sulfuric acid. So it is H2SO4. And then the other part that we need to pop in here is a formula for copper sulfate. So we have copper, Cu, and then the sulfate ion is the SO4 bit. Now, there are a couple of important parts I want you to remember about this, or I want to point out to you about this. When you're writing down your numbers, please make sure they are the right size of numbers. Here, in this sulfate ion, my 4 is the same size as my letters. It needs to be a tiny little subscript number. We cannot have big numbers, and we definitely cannot have numbers up there. We cannot have superscript numbers. You are not going to get marks for those in the exam. So please make sure that your numbers are clearly smaller than the letters and they are clearly superscript numbers. So basically, I mean, the ones down there on the line, the little ones. So then we need to check this is balanced. So the way that I like to check this is balanced is just write a little table out for me. Now, you don't have to do this on the exam question because sometimes this just makes the exam question a bit messy. And when you come back to it later, it's a little bit hard for you to understand. So you can do this on the side of your paper. I'm just going to draw a line down the middle there to remind myself which is the left-hand side, which is the right-hand side. You may feel that doing that is a little bit embarrassing, but remember, nobody but you and the examiner is going to see your exam paper. So if you had to write yourself a little note, a little something that maybe you'd be a little bit embarrassed for your friends to see you doing, just do it in the exam, because the exam is about getting the marks. Your friends are not going to know that you've ever done this. So you don't need to be embarrassed about writing down things that maybe seem a little bit obvious. So I'm talking about things like, you know, when you're doing negative numbers in maths, if you want to write down the number line and actually do the little jumps, that's absolutely fine, not a problem. You do what you need to do to get the marks. So on the equation, I've got my left-hand side and I've got my right-hand side. This is just a shorthand I'm using. Please, in the exam, just write down the words left-hand side and right-hand side. Don't use abbreviations like this because that doesn't mean anything to the examiners. So I'm just going to go through and I'm going to count that I've got the correct number of atoms. So I'm going to go from left to right on the left-hand side of the equation, first of all. So we've got copper, we've got carbon, we've got oxygen, we've got hydrogen, and we've got sulfur. Now I'm going to do the same for the right-hand side, and even though the elements are in a different order on the right-hand side, I'm going to keep them in the same order as the left-hand side, just to make it a lot clearer. Copper, carbon, oxygen, hydrogen, and sulfur. So on the left-hand side, I've got 1 copper, I've got 1 carbon, I've got 3 oxygens here, and I've got 4 oxygens there. So I've got 7 oxygens, I've got 2 hydrogens, and I've got 1 sulfur. On the right-hand side now, I've got 1 copper, I've got sulfur, I've got 1 sulfur, I've got 4 oxygens there, I've got 2 oxygens there, and I've got 1 oxygen there. So that gives me 7 oxygens in total. Then I've got 1 carbon and I've got 2 hydrogens. So I can see I've got exactly the same numbers of everything on either side. So this equation is balanced. I don't need to add anything else to this. In the exam, there are a few hints that the examiner will leave for you. For example, if there was a space or something, that might be an indication that you need to write something in there, but do not feel like you have to try and force too many numbers in to balance an equation. If it's balanced already, it's balanced already. Calculate the relative formula mass of copper carbonate, CuCO3, and it gives us the relative atomic masses. Carbon equals 12, oxygen equals 16, and copper equals 35.5. So this is the way that I always like to lay it out, so it's very, very clear. So we've got copper, 63.5, plus carbon, which is 12, plus oxygen, which is 16, and we've got 3 of those. So if we pop that all into our calculator, we will get an answer of 123.5. And you can see, even though I've done my calculation up here, I've actually written my answer on the answer line to make it very, very clear to the examiner that that is the number that I want marked. That is the bit that I want recognised as my answer, not anything else. So even if I had written my answer here, I would still take the extra 5 seconds to then repeat the answer on the answer line, because that's where the examiner is going to first look for it, and you just want to make it as easy as possible for them. What is the chemical test to show that a gas is carbon dioxide? A, bubble the gas through lime water and lime water turns cloudy. B, put damp blue litmus paper in the gas and the litmus paper turns red. C, put a lighted splint into the gas and the splint is extinguished. D, measure the pH of a gas. It is A. Hopefully you remember that because that is just a recall question, but there are 2 parts that you need to recall there. You need to recall the gas, the lime water bit, and then you need to recall the positive result. So if this was a like a written question, if I just had lines to describe the test for carbon dioxide, then we could word this as something like, you need to bubble the gas through lime water. And then what I'd want you to say to clearly show to the examiner that you knew it was a positive result, and a positive result will turn the lime water cloudy. So it's very clearly showing that you know what you're talking about there. Question 4. When hydrogen is removed from an alkane, an alkene is formed. This is an example of a dehydrogenation reaction. Under certain conditions, dehydrogenation of propane forms propene and a dynamic equilibrium is reached. First part, state what is meant by dynamic in this context. And then for a big 6 marks, the equation for this equilibrium reached is CH3, CH8 gas, a reversible reaction with C3H6 gas plus H2 gas. So propane and the dynamic equilibrium propane. The forward reaction takes in heat energy and is endothermic. A manufacturer produces large quantities of propane using this equilibrium reaction. Suggest, with explanations, suitable conditions that the manufacturer could use to maximize the yield and the rate of productions of propane from propane. So there are 2 parts here. I'm going to leave it like that so you can see both parts. You've got 7 minutes for this question. The first part is very long, so most of that time should be spent on the second part of this 7 minutes. You've got 1 minute left. Okay, let's get that nice little 1 marker out the way, then we can dive into the rest of the question. When hydrogen is removed from an alkane and alkene is formed, this is an example of dehydrogenation reaction. Under certain conditions, dehydrogenation of propene forms protein, and a dynamic equilibrium is reached. State what is meant by dynamic in this context. So whenever it's state, this is a nice, simple recall question. If you're not 100% sure about all of your keywords, now is a fantastic time to start using flashcards to get those keywords in there, because this is just a gift of a mark from the examiners. So when we are talking about dynamic in an equilibrium context, it's because both the forwards and the backwards reactions taking place at the same time. So let's go to our big 6-mark question here. So the equation for this equilibrium reaction is propane to propene. Now, one of the key things I want to point out to you here, now I did talk about this yesterday as well, it comes up in chemistry, comes up in loads of subjects, is making it clear to the examiner different things you're talking about when they only differ by 1 letter. Now, I will be the first to admit that my handwriting is not amazing. Would you be convinced you could tell me which one was propane and propene from my handwriting? If you do not make it 100% clear to the examiner what word you're writing, especially with words like this that differ by 1 letter, so lactose and lactase, or mitosis and meiosis, the examples we had yesterday, propane and propene, they are different things, especially when they're coming up in the same question, and when you're a little bit rushed and stressed, under pressure. Please take the time to write those words out clearly. Even if the rest of it is a little bit rushed, take the time to make sure those words, the ones that are chemistry words, very, very similar spell, are written out clearly. So there is a lot to unpick in this question. The forward reaction takes in heat energy and is endothermic. So our forward reaction is endothermic. We need to produce propane using equilibrium reaction suggest. So whenever we have suggest as our command word, it's going to be taking something that you learn in class, an example you've learned in class, and putting it into like a slightly new situation. So even if you haven't seen this equilibrium reaction before, it wants you to use your common sense to suggest what sorts of things, what sort of reaction conditions are needed. So this is a science plus common sense sort of thing. So if you haven't come across this reaction before, you've probably come across a similar, you've definitely come across a reaction that's been at equilibrium before. So take what you know from that reaction and apply it here. And what do we know about different things? What can we take from this? What can we write down? And there are two things in here. Two things that we need to talk about in the question. And when it's a long question like this and they put two things in there, lots of students will do one and then forget about the other one. But we need to talk about the yields and the rate. So this is a really common, really hard question when they're mixing these two things together, because you will have done them together in class, but you've probably learned about rate reactions and then you've learned about equilibrium reactions, but this is actually combining the two of them. And when we have rates of reaction, when we have equilibrium, there are loads of different things that we can be thinking about. So you can see I've actually been doing quite a lot of thinking before I've even got to writing anything down. So when we're thinking about equilibrium, you know there are lots of things that affect equilibrium. You know there are lots of things that can affect rate of reaction. So that is how we're going to structure our question. We're going to lay this out. I'm going to give you some headings, and then this is how I'm going to lay out the question. So we're going to talk about three things in our answer, because these are three things that we know can affect the rate of a reaction. So that will affect rates. They will all affect rate, but only two of these will affect the equilibrium. It's only going to be the temperature and pressure that affects equilibrium, which is why lots of people will write this and will potentially forget about a catalyst being something that will affect the rate. But it is really important because they have mentioned rate in here. So I've done a lot of talking and now I'm going to do a lot of writing, but you can see that I've actually written down kind of like a semi-plan for this question before I'm going to dive straight into it. So I'm going to have a paragraph about catalyst and how it affects the rate. I'm going to have a paragraph about temperature, how it affects the rate and how it affects the equilibrium. I'm going to have a paragraph about pressure and how it affects the rate and how it affects the equilibrium. So a catalyst will speed up the rate of both forward and the backward reaction. So both the production of both ways, that is what it's going to speed up. So we will get to equilibrium faster, but it is going to have no overall effect on the equilibrium yield. So I've called it a paragraph. It's really only 2 sentences. So now we're going to have a look at the temperature. And then we need to think about the temperature in a number of different ways. So we can say, I'm just going to switch colours to this to make it a little bit clearer for you that I've moved on to a different thing. Obviously, you do not switch colours in the exam. You just use your black biro. So a high temperature will increase the rate of reaction. And then we need to use some information. We can use some information from the question here. So because the reaction is forward reaction is endothermic, it is going to shift the equilibrium to the right hand side. And you'll notice I have written that out in full, right hand side. Do not write the shorthand for that, even if that's maybe what you've done in class, maybe what you've done in your notes. Really make it clear to the examiner that we are talking about going to the right hand side. And now we need to think kind of like what I was talking about yesterday. Well, so what? How can we link this back to the question? So this will result in a higher yield. However, when we are using very high temperatures, this requires lots of energy. And as we know, especially at the moment, keeping things at higher temperatures requires lots of energy, which is expensive. Okay, so now I'm moving on to my third paragraph, which I'm going to talk about the pressure here. What I'm going to do is just rewrite the equation here so that you can see it when I scroll down, because I'm going to be referring to it. You can see what I mean about my appalling handwriting and numbers. So this is where we need to be thinking about the pressure. So one we can look at the number of bits on each side. So over this side we have one thing, and on this side we have two moles of things. So on the left hand side we've got 1 mole, on the right hand side we've got 2 moles. So we can use this to talk about the pressure. So because there are fewer moles on the left-hand side, a lower pressure could be suggested because that will shift the equilibrium to the right-hand side. And because we want to be thinking about the yield here as well as the rate of reaction, if we're shifting things to the right-hand side, we're going to be increasing the yield. However, If we have a higher pressure, that is going to increase the rate but decrease the yield. So for this, whoever is designing this experiment will need to come to a compromise between having a high pressure, which is going to increase the rate of reaction, and a low pressure, which is going to increase the yield of the reaction. Oh, that was quite a lot there. Lots and lots of chemistry to bring in. I didn't necessarily write huge amounts, 3 relatively short paragraphs there, but you can see I split the 3 paragraphs, 1 paragraph per point that I was talking about, and then I linked to both. In each paragraph, I've linked it through to the rate of reaction, how it's affected that, and I've linked it through to the equilibrium and the yields. Question 5. The first 4 elements in group 1 are lithium, sodium, potassium, and rubidium. Rubidium reacts with water to form rubidium hydroxide and hydrogen, and there is the equation. 2Rb, open brackets, solid, close brackets, plus 2H2O, open brackets, liquid, close brackets, turns into 2RbOH, open brackets, aqueous, close brackets, plus H2, open brackets, gas. For the first part, predict what you would see when a small amount of rubidium replaces a large volume of water for 3 marks. B, why is rubidium more reactive than potassium? A, the metallic bonds in rubidium are weaker than those in potassium. B, rubidium is a softer metal than potassium. C, the outer electrons of rubidium atom is further away from the nucleus than potassium's. D, rubidium has a more exothermic reaction with water than potassium does. And then part C, 8.5 grams of rubidium are reacted completely with water. The reaction makes a solution rubidium hydroxide. The volume of this solution is 2.5 decimeters cubed. Calculate the concentration of rubidium hydroxide in grams per decimeter cubed, and then it gives us the relative atomic masses. So rubidium 85, and the relative formula mass in rubidium hydroxide is 102. So done some of the maths that we've already been asked to do before in previous questions. So that is for 4, 5, 7 marks. So I'm going to give you 7 minutes to try this question. After 3 minutes, I'm going to move it down so you can see. I'll leave it there like that for you. And then after a few minutes, I'll move it down so you can see the second part of the question as well. You've got 3 minutes left, so you should be trying the last part by now, please. Okay, this was a big question. Let's just go through all of the answers. So the first 4 elements in group 1 are lithium, sodium, potassium, and rubidium. So it's telling us that even if you haven't seen this reaction in class, hopefully you've seen maybe sodium or potassium being dropped into a large pail of water in class or watched a video about it. Rubidium reacts with water to form rubidium hydroxide and hydrogen. And then it gives us the equation. Predict what you would see when a small piece of rubidium is added to a large volume of water. So it's not saying what do you remember from class when you did this, because I'm not sure anybody would have done this one in class, but you've probably done something similar. And it's predict what you will see. Now, lots of students get confused. They start talking about bonding. They start talking about things that are way beyond the scope of this question. This is a lovely question because all it's doing is, what do you remember seeing when you did this? And it's a great question again, because there are loads of things you could write for this. There are loads and loads of things you could do for this. So if we think back, the metal would have dropped in. It would have been kind of like moving around on the surface, so moving around. As it was moving around, there might have been a flame coming off, or it might be fizzing. And because this is talking about what you see, you would see the metal eventually disappearing. Now, I know it doesn't feel very like chemistry to say things disappear, because we know it doesn't really disappear, but this is for asking what you see. So this is a question where people kind of like try and be too clever and trip themselves up on this, but this is a lovely question. So why is rubidium more reactive than potassium? Now, this is a tricky question because all of these are true statements, but we need to work out which out of all of those actually just is the one that affects the reactivity of it. So if we look at B, rubidium is a softer metal than potassium. Yes, great, it is, well done. But is that in any way affecting the reactivity? No, it's not. So sometimes when you've got multiple choice questions where everything's true, you really need to be careful that you're actually picking the one that answers the question. And the one that answers the question here is that the outer electron rubidium atom is further away from the nucleus. So the nucleus has less hold on it. So our last part here, and this is the last question that I'm going to go over in this session. Sorry. 8.5 grams of rubidium are reacted completely with water. The reaction makes the solution rubidium hydroxide. The volume of the solution is 2.5 decimeters cubed. Calculate the concentration of rubidium hydroxide solution in grams per decimeters cubed. And it gives us a relative atomic mass, and it gives us a relative formulas. So like we had earlier on, if you're not sure where to start with this, always try and go for the moles. Just try and do that, and then maybe we can get a mark. I said earlier, try and work out the relative formula masses and stuff, but they've given us that. So they've kind of taken away one of the go-to places already. But always, always, always go to the moles of this. And the thing that we've been given the mass for is rubidium. So that's what we're going to start by looking for the moles of. And when I'm laying this out for the examiner, I'm going to make it really, really clear what I'm calculating the moles of, so they don't have to go back and kind of like hunt through my calculations, try and work it out. I'm going to make it very clear by writing down moles, so they know that is exactly what I'm doing. So the mass that we had is here. I'm just going to change my color for that because that's a bit dark. So our mass and then our MR. So what we need to do is 8.5, and then we need to divide that by our MR, 85, and that is going to give us 0.1 moles. Great, we've already got our first mark. Now we need to work out rubidium hydroxide, and we need to have moles of rubidium hydroxide. And this is a bit that some people kind of like maybe looking at this, not very sure where to go next. What you need to do always, always, always is go to the equation. Now the equation here is up here, and you can see that rubidium and rubidium hydroxide are in a 1-to-1 ratio. We start with 2 moles of rubidium, and we end up with 2 moles of rubidium hydroxide. So they're in a 2-to-2, we cancel it down, they're in a 1-to-1 ratio. And we can tell the examiner that we know this by writing it down really clearly. So look, there we go. We've got ourselves a whole nother mark there. And we didn't actually have to do any calculations. We didn't have to do like too much. We just had to do it a little bit of thinking, go back to the equation, and then clearly demonstrate that we know what we are talking about to the examiners. We could have put a ratio up here. A 1-to-1, again, clearly showing the examiner that we know there's a ratio. Now, because we need to give our concentration, we need to go from moles, so that we need to find the mass so that we can actually work out our concentration. And I'm going to make it very, very clear what I'm looking for the mass of. So we can go back and look at our question, being told what we've been given. We've been given the MR. We've already calculated the moles. So now we can work out the mass of rubidium hydroxide, 10.2 grams. Now, hopefully most of you will be able to get this first mark, just go to the moles. The second mark, that was a bit of a leap. The third mark, again, that was a slightly tricky one. And this fourth mark here is the trickiest out of all the marks. But 3 out of 4 marks for this question, like I've been saying the whole way through, is very, very respectable. If you're aiming for those 7s, those 8s, and those 9s, you do not need to be getting 100%. You do not need to feel worried about getting 100% on everything. 3 out of 4 marks on a tricky calculation like this is more than enough. But to get that final mark, because we are looking for the concentration in grams decimeter cubed, and this is the hard part here, the really hard part of this, is what we need to do is we need to take the number of grams, which is 10.2, and we need to divide it by the volume here. Now, there is a clue in the unit because it is grams divided by volume. So find the thing that's in grams, find the thing that's in volumes, and divide them by each other. So your answer is 4.08 grams per decimeter cubed. And that is the last question that I have for you today, guys. Thank you very much for taking time out of your busy day. I know after school, you're probably all really tired to come and join me for this. And hopefully I will see you again for physics tomorrow.